Hi everybody. So we're starting in Chapter 5, Section 5 today in Pre-Calculus. It's April 6th, and these are the double angle formulas. So we're going to look at three different formulas, one for sine, one for cosine, one for tangent. First one is the sine of 2 times u is equal to 2 times the sine of u times the cosine of u, where u is some angle. The next one, cosine of 2u, actually has three different formulas, and you choose which one to use depending on the information that you're given. The first one is the one that I use the most, and it is the cosine of 2 times some angle is cosine squared of u minus, oops, that's not a minus, minus sine squared of u. Another cosine of 2u, you could also write equals 2 times the cosine squared of u minus 1. And one other formula is 1 minus 2 sine squared u. So all three of these equal the cosine of 2u. But I'll tell you right now, the one I use most often is that first one, cosine squared u minus sine squared u. And then the third formula we're going to look at is the tangent of 2u. And there is a specific formula that uses the tangent of an angle, but remember we've learned a long time ago that tangent is just sine over cosine. So honestly, for all the problems you're going to do for the homework, you're going to have to find the sine of 2u and the cosine of 2u anyway. So the easiest way to find the tangent of 2u then is just the sine of 2u divided by the cosine of 2u. So there is another formula that's written in the book, but it's not one I think that you'll ever have to use. And these, like all the other formulas we've learned so far, you're not going to have them memorized. You're going to be given these formulas on a formula sheet. All right, so make sure you get these formulas written down because I'm going to erase this and we're going to do some examples. As soon as I find my eraser, so you've got plenty of time. Okay. So we're going to have examples of using these formulas. All right, so example 1. And I'm going to set it up first. Suppose we are given that the cosine of theta, so this time I'm using theta instead of u, it's just a variable, it doesn't matter what is used. Suppose the cosine of theta is 5 over 13, and we know this. 3 pi over 2 is less than theta is less than 2 pi. Then we are going to find, and number 1, we're going to find the sine of 2 times theta. So we know the cosine of just theta is 5 over 13. We don't know what angle theta is, and we don't need to find out what it is. We're going to find the sine of twice that angle theta. All right, so let's look at this. 3 pi over 2 is less than theta is less than 2 pi. So why in the world would they give us this information? Well, this is just to tell us what quadrant our angle is in. So if our angle is between 3 pi over 2 and 2 pi, let's just review that. Here's 3 pi over 2 down here. 2 pi is back where we started from. So we are in quadrant 4. So in quadrant 4, remember that the cosine is positive, so the sine is going to be negative. All students take calculus, means that cosine's positive, sine's going to be negative. That's going to come into play in a little bit. All right, so just like we did on some examples we did last week, we know the cosine of theta. The sine of 2 theta, the formula for that is 2 times the sine of theta times the cosine of theta. Well, we know the cosine of theta, that's given. What we don't know is the sine of theta. But just like what we did last week, we can draw a triangle for theta. I think I'll do it over here. All right, so here's my theta. The cosine, they tell us, is 5 over 13, and cosine is adjacent over hypotenuse. So the sine of theta is going to be the opposite over the hypotenuse, so we have to find this missing side again, and it's one of our Pythagorean triples. If you don't have those memorized, you can just use the Pythagorean theorem, but this missing side is 12. So now our sine of theta is going to be 12 over 13, but we have to go back to the fact that we're in quadrant 4. And in quadrant 4, sine is negative. Remember, you're never going to get the negatives out of the triangle. The answer being positive or negative always comes from the quadrants. So now that we know the cosine of theta and the sine of theta, we can simply plug those values into this formula and get 2 times negative 12 over 13 times the cosine, which was given as 5 over 13. So that's going to be 10, so that's negative 120. 13 times 13 is 169, and that's our answer. So we didn't figure out what theta was, but we know that the sine of twice theta is negative 120 over 69. Second example, let's find the cosine of 2 theta. Now there were 3 different formulas we could have used, but I'm going to use the cosine squared theta minus sine squared theta. And don't get that confused with the Pythagorean identity that we know that sine squared theta plus cosine squared theta equals 1. This is cosine squared theta minus sine squared theta. And the reason why I chose that one is because I know what the sine of theta is. I know what the cosine of theta is. So I'm just going to plug those values into this formula. Remember that cosine squared theta means the cosine of theta squared. So I know the cosine of theta was given as 5 over 13. We're going to square that. Minus sine, which is negative 12 over 13, squared. 5 over 13, you square the numerator and the denominator. That's going to be 25 over 169. Minus, when you square this negative, and you do square that before you subtract, so when we square this negative, it's going to be a positive 144 over 169, but then we have to subtract it, so the minus is still going to be there. So this gives us negative, what is that when we subtract it? I'm going to abracadabra that. Where'd it go? Negative 119 over 169 for our cosine. And then finally, let's find the tangent of 2 theta. So the tangent, and I'm just going to use an old definition that we know, is just sine over cosine. So it's the sine of 2 theta over the cosine of 2 theta. Sine of 2 theta we found in the first example is negative 120 over 169. Cosine of 2 theta is negative 119 over 169. First of all, the negative over a negative, I know my answer is going to be positive, so I'm going to ignore the negatives now. So that's 120 over 169 divided by this fraction, so it's going to times the reciprocal of that over 119. And again, I'm not writing the negatives because they already canceled each other out, just like these 169s do. So our answer for the tangent is 120 over 119. All right, so there's our first example. Okay, that's when they just tell you the trig value, one trig value of your function. Then you're going to want to draw a triangle to find whatever's missing, and then you can plug it into your formulas. All right, second example is going to be a little bit different. But we're still looking for the same information. It's just going to be given to us in a different way. So for these examples, what if they tell us to use the figure to find? All right, and this is going to be the figure that we're given. Let's switch our triangle around just to keep it interesting. So suppose they give us this right triangle, and we have theta here. Suppose they tell me this length is 1, and this length is the square root of 3. All right, so the first thing we're going to find, and this would be example 4. We just did examples 1, 2, and 3. Suppose they want just the sine of theta, not even 2 theta, just the sine of theta. Well, the sine is going to be the opposite over the hypotenuse. So, oops, we're missing the hypotenuse here. This isn't one of our Pythagorean triples. So if I call this x, I'm going to have 1 squared plus the square root of 3 squared equals x squared. So that's going to be 1 plus 3 equals x squared. 4 is x squared, so that means x has to equal 2. So that's going to replace my hypotenuse there. So my sine is the opposite. Here's theta, so it's the opposite over the hypotenuse. Number 5, what if they want just the cosine of theta? Not of 2 theta, just plain old cosine of theta. Again, cosine is adjacent over hypotenuse, so that's going to be 1 over 2. And now the reason why they had us find that is because example 6, let's find the sine of 2 times theta. And again, the formula is 2 times the sine of theta times the cosine of theta. And aha, that's why they asked us to find these two things first. So that's going to be 2 times the square root of 3 over 2 times 1 over 2. So that gives me, let's see, I can do some canceling here. I'll cancel these 2's. So I'm left with just the square root of 3 over 2. Number 7, cosine of 2 theta. I am again just going to use that first definition. It's the cosine squared of the angle minus the sine squared of the angle. So cosine we found to be 1/2. So it's going to be 1/2 squared minus sine square root of 3 over 2 squared. When you square a fraction, you square the numerator and the denominator. So that's going to be 1 over 4 minus, when you square the square root of 3, you just get 3 over 4. So that's negative 2 over 4, but that's going to simplify to negative 1/2. And finally, let's go ahead and find the tangent of 2 theta, because that's what they're going to ask you for in the homework. And I just like to go back to our definition of tangent as being sine over cosine. So since we're finding the tangent of 2 theta, it's going to be the sine of 2 theta over cosine 2 theta. So let's see, we found sine 2 theta in number 6. That was the square root of 3 over 2. Cosine was negative 1 over 2. So that's the square root of 3 over 2 times the reciprocal of negative 1 over 2, which is going to be negative 2 over 1. So ultimately that gives us the negative square root of 3 over 1, but we don't need to write over 1. All right, so that's all the examples you need for your homework. Good luck with it. I know you can do it. Don't forget to submit it on campus. Have a great day.